Welcome to Cloud on Air, live webinars from Google Cloud. My name is Lack, and I'm going to be talking today about public data sets on Google Cloud. We have Googlers available on standby to answer questions, so please ask questions on the platform. So when we're talking about public data sets, we of course start with what's available. What kind of public data sets are there? There are essentially three different types of public data on Google Cloud. The first of them are the data sets that are on Google BigQuery. BigQuery is, of course, the data warehouse in Google Cloud. It's a good place to store structured data sets because you can query them using standard SQL. You get querying up to 1 terabyte per month for no charge. And to just show you the kinds of things that are available, I'll go to this website, console.cloud.google.com/marketplace. So I'll go into the marketplace, and you can scroll down and you see that there are data sets available. But instead of going ahead and clicking on these data sets, I could basically go ahead and say, let me go ahead and find New York City 311 data. So 311 in New York City is where New Yorkers call in with complaints, municipal complaints. So we can go there, click on this data set, and in addition to viewing the data set, there are a couple of example queries available. So let's go ahead, and this sounds very interesting. Which New York boroughs have the most number of parties? If you decide to move to New York, where do you want to go live? So let's go ahead and run this query. And what I'll do is I will go ahead, wait for the query to load. And this is the classic UI, but I love the new UI in BigQuery. So let me go ahead and switch to the new UI. So that is the query. And let me go ahead and run the query. And there we go. The query basically says, matter of seconds, that the borough is, in Brooklyn we had 110,000 or more parties, and so on, right? And this is the different party days, 1 being Sunday and 7 being Saturday. And as you would expect, most of the parties are on Saturdays and Sundays. Although Manhattan seems to have some parties on Fridays as well. So where are the really loud parties? Well, one thing that we did was we just went ahead and did the query, but let's go ahead and do something cooler. Let's go ahead and explore this data in Data Studio. So what this is doing is that it's going ahead and running this query for us, and I will change, right now this is basically based on the record count. So let me go ahead and change the metric to be the number of parties. And instead of doing the sum, let me choose the max. And let's change this to be a bar chart. And there we go. Brooklyn has the most number of parties, followed by Manhattan, followed by Queens. And we saw how easy it was to go from a data set to do a query and to go ahead and display it using Data Studio. So what was different about this? And it's kind of good to step back and say, okay, what exactly was different? So sure, I showed you going to a website, running a SQL query, and then going into another website and visualizing the data all in one workflow. So great. But the key thing that's different here is that the data didn't actually move anywhere. The data was there in BigQuery. It was there on the Google Cloud. And what we did was that we brought a whole bunch of compute to this data. So if you were to go to this data set, so let's go ahead and view the data set. And let's see. There is a 311 service requests. And look at the details of this data set. That was almost 9 gigs of data that we queried in a matter of seconds. How is that possible? The only reason it's possible was because we threw thousands of machines on this one SQL query to execute it. And there is no way that this data was present on those compute nodes. Instead, just like these birds flocking over a sea, we brought a bunch of machines to go ahead and process the data in a distributed form and give us the answer back. So if you were to think of what the old world was in terms of data analysis, the old world was to go ahead and download data to your laptop, analyze the data, and then distribute the results. But that old world doesn't really work anymore. And the reason it doesn't work is that the kind of data sets that we are now dealing with are much, much, much larger. If you take an industrial use case, you're probably producing anywhere from half a terabyte to 4 terabytes per machine per year, or healthcare, a typical hospital have more than a terabyte per month, or transportation, you have about 2 gigs of data a year, and if you're in retail, you may be collecting up to 4 gigs of data per day per product line. This is a lot of data, and when you think of that kind of data, this old workflow of where you start with downloading data, it doesn't work anymore because data doesn't fit. The other thing that happens is that when you want to do your processing, there is a lot more compute power available on the cloud. And especially when it gets into things like machine learning. What's shown here is a tensor processing unit, a TPU, a custom ASIC for machine learning. And if you want to do machine learning on large data sets and do them in a fast way, you need to be able to access hardware like this. And at that point, thinking of analyzing data on your laptop, it doesn't really work because you need lots of compute to be able to do your analysis, to do especially your machine learning on data sets this large. And the third aspect of this is that in the old world, you would distribute reports. It was okay if you just gave somebody a PDF. But these days, everyone is used to interactive reports. They want to be able to do what I just did in Data Studio, or what you do when somebody sends you a map. They don't send you a PDF of a map, they send you a Google map that you can then go ahead and interact with. And that's true of charts, that's true of documents. People are used to interactive reports, and so when you distribute the results of your data analysis, they need to be interactive. And so the old world where you downloaded data, analyzed the data on your laptop, and then emailed your results as a PDF, those don't work anymore. So the new world is a world in which you need to analyze, share your data, and do your reports. And so what I just did in that demo of finding the boroughs in New York with the most number of parties, that illustrated this new world where the data stays in place and you bring your analysis to it. And that is what public data sets on Google Cloud are about. It's about the data staying in place and being able to do massive amounts of compute on the data and to be able to provide the results of that analysis in a form that your end users can still play around with, can interact with, can query it themselves as well. So the whole idea here is that we started with a data set, and having gotten the data set, we went ahead and clicked on the query, and then we ran the query, and then we clicked on Explore in Data Studio, and then I was in that interactive report, and I was able to go ahead and change the way I displayed the data and edit the data. And all of this is possible, and with Data Studio, I can share these things, and it's all possible because it's all on the cloud, and the data remains in place. I mean, there's no way you can think of moving 9 gigs of data around every time you want to do analysis like this. The data needs to stay in place, and you need to bring compute to the data. But this is not just about analysis. So what I just showed you with parties in New York was about analysis. But what's a new cool thing? Machine learning. And so even in BigQuery, right, with our data sets, we can actually train a machine learning model, and this time I'll pick a data set also from New York to predict a taxi fare. So given the pickup location and the drop-off location, I would like to basically figure out what would the taxi cost, and in order to do that, I will go back and look at historical data of all kinds of taxi trips and what was the actual amount paid by passengers taking those taxi trips. And this will allow me to demonstrate BigQuery ML and also BigQuery GIS, because this is a spatial data set. People get picked up at specific locations, dropped off at specific locations, and rather than do it from the user interface, BigQuery user interface, this time I'll do it from a Python notebook. And I'll also show you another cool tool called a GeoMapper or GeoVis. So going down here, so this is a GitHub repository that contains a taxi fare model. So this is a Python notebook. I just loaded it into Data Lab, which is a Python notebook environment. I can go ahead and in Data Lab, I can click on a cell and I can run the cell. And this allows me to run it. And let's see. So we can go down here, do the Python imports. And here now is my BigQuery query. So the key part of this query is that I'm selecting some number of rows from a table of New York City taxi trips. So I can go ahead and run that. And then I can say, go ahead and execute this query, and I get 1,000 of them. And I can look at the top few records. And there's my trips.head, and so on. Okay. And so we can go ahead and look at the description of those things, but that is at this point just still data analysis. So let's look at this line. This is the line that does the machine learning. So take your query that pulls in records, and in this case, I'm pulling records that contain the hour of the day, the pickup longitude, the pickup latitude, the drop-off longitude, the drop-off latitude, all of which come from the data, and the total fare that was paid, and that also comes from the data. The total fare being the actual fare amount plus any tolls, etc. So those are the columns, and I say, please go ahead and create a machine learning model to predict the taxi fare using a linear regression model. And the rest of these things are optional. So we can do that, and at this point, we can go ahead and say, run this query for me. I don't want to overwrite the query I already have, so I'll call this demos2, and I'll go ahead and say, run the query. Oh, I need to run this still, and then run the query, and we can then go ahead and execute the query, and this takes about 5 to 10 minutes. So I'll let that execute, and I'll assume that it's already done, and I'll just move on to what you would get at the end of it. So after that, what you will get is that in BigQuery, there will be a model that's created that is capable of doing this prediction. And notice that all that we really did was that we took a normal BigQuery query that did the standard SQL and added 3 lines. Go ahead and create the model with this particular algorithm to predict this column based on all these other columns. And at that point, we also get back the training loss. As the error decreases as the model trains, we can evaluate it on another independent data set. So this is just another BigQuery query where I'm doing a select of from an ml.evaluate. And then I can go ahead and look at the errors, and the errors turn out to be about $6 on average. And then we can also go ahead and evaluate it based on, okay, so we have $6 an average error, but does the error change depending on where people were picked up or where people were dropped off? And so what I can do is that I can go ahead and select the total fare. I can go ahead and find the error and group it by dollars, group it by the amount of fare. And if I did that, I would find that the errors are really small when the fare is around $11, and it increases quadratically on each side. So it basically, on very expensive trips and very cheap trips, the errors are very high. And so this says, well, we need to do something else. So what I'll do is I'll go ahead and add the st_geographic point, which is a spatial query in BigQuery. So this allows me to basically treat a pickup longitude and pickup latitude not as 2 independent points, but as one point, a pickup point. And having gotten that pickup point, then I will go ahead and compute the distance, st_distance, between the pickup and drop-off point. And I'll use that as one of my training variables. So even though this is not present in the original data, I'm now using some geospatial functions to go ahead and create a new feature. And when I do that, long story short, my errors become very flat across all of these dollar ranges. So I'm actually learning to predict much better. And then let's go ahead and visualize it. And let's look at how these errors change based on location. So what I'm going to do is that I'm going to basically take this query, which what it does is that it groups these things by drop-off grid point. And I'll go to the BigQuery GeoViz and put my project ID in there and say that I want to run that query. Okay, and run that query. Okay, so there it is. So see the results, and I'll change it to the drop-off grid point, and I see my results here. Let me go ahead and change the style and change the fill color to be data-driven and make it a linear interval. And let's go ahead and do the range of that color, and maybe from 0 to 20. And the field could be the mean absolute error. And let's go ahead and do that. And you see that the colors are different, but at this point, my original data, the resolution is actually pretty small because I did resolution of 0.1 degrees. Let me change that to 0.01 degrees. So now I get a lot more points. I can go back to my style, and there we go. And as you can see, let me change the color a little bit. Okay. Cool. So you can see that the errors are low in Manhattan, and as you go further and further away into Brooklyn, etc., the errors increase. And this is a kind of visualization that we did relatively quickly on the map. So let's move back here. Okay. So cool. That was great. I just trained a model, machine learning model, based on a public data set, the New York City taxi cab data set, to predict taxi fare. So I said there's different types of public data sets available on Google Cloud. I spent about 15 minutes sidetracked on BigQuery. So let's now talk about what else is available. So we started talking about 3 types of public data. The second type of public data that's available on Google Cloud is the Google Genomics data. So genomics data consists of 2 parts. You have some data sets in BigQuery. These are things like variants, etc. You have another data set on cloud storage. These are like the BAM, VCF files, and so on. And there is a link if you want to learn more. But one of the things that you could do is that you could actually go ahead and use BigQuery. Okay. You could use BigQuery to go ahead and run a query like this, where you are joining against your own table against a 1,000 genome data set, for example, to figure out something about the variance. And I won't embarrass myself by talking too much more about genomics because I don't know too much about it. But there is a data set where you can actually compare a particular genome that you have against one of the public genomes. The third type of public data set that you have are geospatial data sets. Geospatial data sets like Landsat images or Nextrad images. These are images that are present on Google Cloud Storage. So not in BigQuery anymore, but in Google Cloud Storage. In some cases, the metadata, what files are available, what times are available, etc., are present in BigQuery, but the actual data themselves, the raster data, is on cloud storage. And also we have, of course, the Earth Engine datasets, which is another huge amount of geospatial datasets that are available for use as well. So what is the point of this? So I said initially that public datasets are about bringing compute to the data, and I showed that with the case of BigQuery, where we had these large datasets and we were able to do SQL queries on that dataset. Well, when you look at geospatial datasets, it's exactly the same way. You have your public data sets in cloud storage, and you will be able to process them with the data in place. But this time, the processing typically happens in Cloud Data Flow. Cloud Data Flow is an execution environment for Apache Beam pipelines. And you can write Apache Beam code either in Python or in Java. So you have two SDKs, two APIs. So you write your code in Apache Beam, Python or Java, and you run it in Cloud Dataflow. So it's loosely like how you write standard SQL and you run it in BigQuery. So you do Apache Beam and you run it in Dataflow. And as an example, let me show you so hurricanes are in the news today in the US, with Florence just having been here. So let's look at an earlier hurricane, Hurricane Maria, and I'll basically show you how to process weather data in real time in BigQuery and in Dataflow. So the idea here, so here's a blog post, and I'll just walk through it a little bit. So there is a BigQuery public data set that consists of NOAA hurricanes, all of the hurricanes all over the world. Basically, you can go ahead and get the latitudes, the longitudes, the time that they were. And in this case, I'm saying find me a hurricane whose name has Maria in it, and from 2017, and order it by ISO time. So what I'm going to now get is the full path of the hurricane. So I have the latitude and longitude that Maria was in, and the time at which the hurricane was at that location, and how far away from landfall was that particular hurricane. So from this time step, right, what I'm going to then do is that I'm going to go ahead and look inside the Google Cloud public data set. I can go say find out my satellite data for that particular year, for that particular date, and we can go ahead and pull up the appropriate satellite data. So we can go ahead, go to this public bucket. So this is a public bucket, and this is where the public data set comes in, and we can pull up that particular timestamp. And having done that, this is in a format called netcdf, and you have Python code or Java libraries to be able to read it. So in this case, I'm using the Python library to read netcdf files, and I'm reading those and I'm plotting them using matplotlib. So you can basically go from BigQuery, figure out what it is that you want to access the data using Python. It's just data in cloud storage, and you can do all of the kinds of things that you would normally do with satellite data. What gets interesting though is if you want to process large amounts of data all at once. And so that's what the next part of this is showing. So this is now an Apache Beam pipeline where I'm saying, go ahead and run this hurricane query, and for every row of the hurricane query, find me all of the GOES files, the satellite data files at this particular latitude and at this particular longitude, and convert them into JPEG. So at that point, I will then get on Dataflow an auto-scaling pipeline that processes, in this case, it's getting all of the hurricanes everywhere, and then basically creating a separate loop for every one of the hurricanes, a kind of distributed processing that allows you to process terabytes of data at scale over hundreds of machines if you need to. And this is the plot, for example, of Hurricane Maria. And the other thing you can do is that you can also listen to PubSub, which is a real-time data feed. So every time a new satellite image hits cloud storage, we publish an event onto PubSub. So you can go into PubSub and you can listen for that PubSub message, and you can do some processing. So what I'm doing here is I'm doing very simple processing. I'm basically going ahead and cropping out a part of the image that corresponds to Seattle, and I'm basically saying here's the satellite image over Seattle at this current point in time. But as with the hurricane data, you can do this for every city in the US, you can do it for different areas, you can create loops, you can do all of those kinds of things. And the cool thing is you can do them all in real time. So with that, right, I'll basically leave you with some resources. First of all, shameless plug for my book. If you're interested in doing data analysis, data science, machine learning on Google Cloud, there is a O'Reilly book, Data Science on Google Cloud Platform, written by yours truly. The second thing is that we have a number of courses on Coursera, and if you're watching this webinar, go to coursera.org/data Next Extended, and you will get 1 month of courses free on the platform. So please take advantage of it. And finally, if you go to Quick Labs, there's a variety of labs, including many of the things that I demonstrated are as labs that you can try out yourself. And that's a wrap. Stay tuned for live Q&A. We'll be back in about a minute. Welcome back. I'm taking questions right now. So if you have more questions, please add them to the platform. So first question, how often are these public data sets updated to reflect new data? Great question. There are some data sets, for example, the satellite data that I just showed you. That satellite data streams into the cloud, and so we actually have new data every time there's a new image that's downloaded from the satellite. So if you're taking over full disk, it's every 15 minutes, but lots of times you have new data every minute. So it is near real time for cases like Landsat data, for cases like Sentinel, for cases like the GOES data. For the BigQuery data sets also, if you're thinking, for example, the city bikes data and or the GOES temperature or the GSORT temperature data, the weather data, all of those kinds of things, as and when new data is available from the public data set provider, that data is reflected on Google Cloud as well. So the answer to how often are these public data sets updated, it is like we try to keep them as up to date as we can. Some data sets like the zip codes data set, we might update like once a year, the utility data sets. But for the most part, as a rule of thumb, the public data sets are as up to date as the provider of the public data sets allows us to be. Second question, how do you decide which data sets to feature on your public data sets program? This is where you can help. If you have suggestions on what data sets we should be featuring, data sets that you would find useful, please do let us know. And remember that even though I talked about public data sets on Google Cloud, there is a lot of public data available out there. There's data on Earth Engine, there's data on Kaggle, and to some extent, our goal with the Google Cloud Public Datasets program is to focus on datasets where it's large enough or it's useful enough that it's going to, so number one, it's very large, so you need to bring compute to the data. So we want to basically feature it to make it easier for folks. The second reason is that it's a very useful dataset. Like the zip code dataset is not very large, but it is an extremely useful dataset. So we will have it as a utility dataset, so people don't have to, each individual company doesn't have to do that. So so we either do it as a public good or we do it as because it's a very large compute thing, even though like genomics data is not very widely used, but it's very useful and it's very large, so we tend to feature it. And the way we decide is, please let us know. And if you're a provider of data and you would like your data to be featured on Google Cloud, also do contact us. There's two ways to do it. We can do the public data set, but we can also do the Google Cloud Marketplace, which allows you to monetize your data set. Third question, you showed a number of links. How can I get a copy of your slides so that I can visit those websites? Good point. If you stick around in the Q&A, we will post a link to my presentation so that you can actually get access, and then you can go to that link, and then all of the other links are available. So feel free to explore. My deck has lots and lots of links, and each of them is a great set of things to go ahead and explore. So strongly encourage you to do that. Fourth question, that's a cool one. BigQuery machine learning seems very cool. When should I use BigQuery ML versus TensorFlow? That's a great question. So I just showed you BigQuery ML, like a little bit of SQL, and you basically have a machine learning model. It's amazing. So what's all this thing about this whole TensorFlow stuff? Do we need it? What is it about? Well, the thing to realize is, number one, BigQuery ML is about structured data, And in many ways, if your data set is very large and it's very sparse, in other words, there's a lot of categorical columns, BigQuery ML will be very competitive with the TensorFlow model. So BigQuery ML would be great for large data sets with lots of columns and especially lots of categorical columns that have lots of values, what I'll call a sparse data set. For all other types of data, TensorFlow is a great choice. So if you have image data, you have time series data, you have dense data sets, you have data sets that involve a mixture of these things, TensorFlow is a much more flexible, powerful framework. The way I like to think of BigQuery ML is that BigQuery ML is a great way by which, rather than writing TensorFlow code to write a machine learning model, you get to express your machine learning model in SQL. So think of BigQuery ML as SQL is the user interface. And in the future, I can easily imagine a world in which you write your model in SQL, but it doesn't get executed in BigQuery ML. Instead, it gets executed in TensorFlow on Cloud ML Engine. But the way you express your model could be as SQL. So maybe you want to do the separation between SQL as a UI, which is very, very, very attractive, and SQL as an execution engine, which may or may not be limited in what it can do. But I agree with you, BigQuery ML is super cool. Final question looks like, are public datasets available to be used on other cloud providers' platform also? A good question. So the public datasets are public, right? So many of them you can access them, but something like a BigQuery dataset, you would have to transfer the data. It's really, I cannot imagine how you would be able to use it from another cloud provider. On the other hand, the Google Cloud Storage datasets, you can absolutely, you can access it from another cloud service provider, but typically there might be an egress fee involved because you're actually crossing a network. But other than that, yes. So if there's a public dataset on Google Cloud on cloud storage and you have your code in some other cloud service provider, you should be able to access it the way you would access any other data on GCP. So it is an open platform, you will be able to access it, and you should be able to do it. So even if it is in BigQuery, and now one option might be to basically run an extraction or run a query to extract the part of the data set that you care about and then transfer that data over and process it somewhere else, on-prem or in some other cloud provider. Okay. Any other questions? All right. And I guess that's a wrap. Stay tuned for the next session, CETV, Application Observability with Lightstep. Thank you very much.